Can we start? Ian, go ahead.
Great. Welcome, everyone, to day two of Healing Earth, an annual two-day discussion forum, now in its fifth edition. So it's called Healing Earth 5.0. And I'm Ian Stewart, and I jointly direct the Centre for Climate Change and Sustainability, which alongside Professor Gautam Menon, who's also joining us today. And that's the flagship, this is the flagship activity really of the Centre for Climate Change and Sustainability, also known as 3CS. 3CS itself is 5 years old, so it's been around for about less than half the time that Ashoka itself has been around. And it was first conceptualized and put into existence by our previous Vice Chancellor, Professor Malabika Sarkar. And she argued that every university should have a centre for climate change and sustainability, given the importance of these topics to our future. It was established in 2019. It's a multidisciplinary initiative addressing the multifaceted challenges of climate change and sustainability. It comprises over 30 faculty members spanning 9 departments, including biology, economics, environmental science, and media studies. And it fosters interdisciplinary collaboration to study, communicate, and mitigate the impacts of climate change on society, health, and environment. That work spans 7 thematic areas. It's ecology and conservation, One Health, climate and society, economics of climate change, climate communication, environmental humanities, and sustainable communities. And these domains guide research projects that tackle studies as diverse as zoonotic spillovers, analysis of climate-induced shifts in fisheries, and the development of cost-effective air quality monitoring systems. Another key initiative, things like the 3CS Media Fellowship, which supports climate journalism from marginalised community. And of course, the event that we're at today, the annual Healing Earth Conference, which has over the years convened experts to discuss subjects as diverse as One Health, climate change economics, and climate change communication. So now I'm going to pass over to Professor Gautam, and he can take you through the topic for today and take you through the programme for today. Gautam, over to you.
Thank you, Ian. So welcome to the second day of the flagship meeting of the Centre for Climate Change and Sustainability at Ashoka, or 3CS as we call it. My name is Gautam Menon, and I work at Ashoka University. My own interests are largely in epidemiology and public health, and they center on how human, veterinary, animal, and ecological health must be thought of as an integrated whole. And coming from that perspective, thinking about the importance of water is very natural. Today's program is titled We Need to Talk About Water. Now, speakers and panelists today are, in the order in which they will speak, Vishwanath Shrikantaiah, Suvimal Ghosh, and Shripad Dharmadhikari. I will introduce each in turn before they speak in more detail. They will all speak for 20 minutes each, approximately. And after all have spoken, we'll take a very short break and then come back for a panel and a Q&A discussion. During this discussion, we'll take questions that you can enter into the Q&A panel. We can take any additional questions for the panel at that time as well. I must apologize for the fact that this is a manel. In fact, it's the first manel in 5 years of Healing Earth, and I'm very embarrassed that this is the case in a panel that I'm responsible for. The speakers I did invite couldn't make it, and it was too late to look for replacements, but I hope to restore the balance of the universe in a future meeting that addresses similar questions. I don't think we need to talk about water as a particularly original title, but it's the title of a piece I wrote some months ago. I pointed out that many problems we might think of in unrelated areas of sustainability, unbalanced migration, the lack of food security, air pollution in northern India, had links to water. And I use these and other examples to suggest that water should naturally be placed at the center of our thinking about sustainability. And I think this is largely the philosophy of the speakers here today. So let me summarize some of these questions to set the Indian context. The Indian and world population continue to increase. India's numbers will level off at about 1.8 billion in 2050 by current trends before it begins to drop. The world population will increase from 8.1 billion to a bit more than 10 billion by the end of the century. All of this will lead to increasing demands on global water supplies. Water supply shortages, whether they're for human, industrial, or ecosystem needs, lead to water insecurity at the local, regional, and global levels. In past decades, we've seen interstate conflicts such as Tamil Nadu and Kerala and Karnataka over the allocation of Kaveri waters, as well as ongoing arguments between Delhi and Haryana and Punjab. Very recently, India suspended the Indus Water Treaty with Pakistan. Our relations with two of our neighbors, Pakistan and Bangladesh, are very reliant on treaties that govern water use that have been extensively negotiated and continue to be litigated. The problem is not so much that the quantum of water the subcontinent receives in the rainy season is lacking. It arises both from the fact that we receive the bulk of our rain only in a concentrated 3 to 4 month period. To meet water needs during the lean months, when surface water flows are low, we rely largely on groundwater. This reliance leads to severe depletion. India is the largest extractor of groundwater in the world. The main problem is that India has been unable to achieve a balance between the use of groundwater and the need to prevent its depletion through measures to systematically replenish it. Vishwanath will describe practical measures to address some of this in his talk. Shortages of water are driven by many factors. These include overexploitation, the mismanagement of natural resources, climate change, and a lack of appropriate infrastructure. All of this also happens in the background of increasing urbanization and a growing population. Our water infrastructure is archaic and prone to breaking down, and our water governance is wanting in many ways. Ecologically speaking, deforestation can lead to the drying of rivers and streams post-monsoon periods because of high runoffs. Climate change will only make things worse and not better. Leakages are significant. India's urban water management systems need to prioritize upgrading and replacing major parts of the distribution infrastructure. So Vimal will talk about how anticipating extreme events and their consequences may help to ameliorate some of this. Industrial development in rural India has transformed a number of Tier 2 and Tier 3 cities into industrial hubs. But inadequate attention to pollution standards and monitoring has affected water quality in rural communities, in particular by pollutants contaminating groundwater. This is leading to significant migration from rural and peri-urban areas. The recent GBS cases in Pune point to water contamination, whose roots lie in unregulated supplies operating in a regulatory grey zone within an urban context. From a few decades ago, even in my childhood, when it was unthinkable to pay for water, today in virtually all of urban India, we pay for the ubiquitous bubble tops, bottles, and sachets of water. We have abandoned the idea that this is a resource that is part of the commons and that private profit should not govern its accessibility. I hope Shripad will address some of these related issues at a more philosophical level in his talk. Having set the stage, let me introduce our speakers. Our speakers today are combinations of activists, educationalists, and academics. Some wear multiple hats, moving between these roles. I think all of you have backgrounds in engineering. Vishwanath is a civil engineer and an urban planner by qualification. Vimal is the Institute Chair Professor in the Department of Civil Engineering and the convener of the interdisciplinary program in climate studies at the IIT Bombay. Shripad is an activist and researcher and the founder coordinator of Manthan Adhyayan Kendra, a center focused on analytic and advocacy work in the water and energy sectors. Let me begin by telling you about Vishwanath in a bit more detail, and then I will pass it on to him. Yes, Vishwanath has 39 years of experience in the water, wastewater, and sanitation sector, helping design rainwater harvesting, aquifer recharge, wastewater recycling, and eco-science systems. He was a visiting faculty and taught an interdisciplinary course to students of public policy and development on the theme water at the Azim Premji University. He is a trustee with the Biome Environmental Trust. He is a technical committee member with the Bangalore Water Supply and Sewerage Board, the Rural Development Engineering Department, Government of Karnataka for the Jal Jeevan Mission scheme. He will speak today about harvesting rain, reviving lakes and wells, reusing wastewater, some experiences in working with local water solutions around the metropolis of Bangalore. Do start, Vishwanath.
Thank you, Gautam. So let me just try and share my screen and make sure that it's visible. And
yes, it's perfectly visible. Just go to full screen.
There you go. But thanks, Gautam, for the quick introduction, and also Ayan and you for setting the stage and explaining why we are here together for this conversation around climate scenario and especially water, where you were talking about what sustainability means and what the challenges are around water and its use in the Indian context, as well as access. I'll just talk very briefly, and I call it the circular water economy, the case from Bangalore and surrounds. And I'll talk about some of the experiences that I've had around Bangalore city and surrounding areas. Starting off as a civil engineer, but more recently learning to see water through a social lens. Typically, my eyes were opened in terms of the theoretical sense long back when we're reading books, but once we start to work on the ground, it really shows a different light for you. One of the sort of work that we are doing with Biome Trust with a partner organization called Arohana, which is an all-women's NGO in a small place called Mulbagal, which is about 100 kilometers from Bangalore in Kolar Taluk. Here, as you see on the photograph on the right, we are working with Arohana and the Gram Panchayat of Omittur to revive 22 tanks or lakes, as they're called, in this particular Gram Panchayat and see what difference does it make to the lives of the people in Omittur Gram Panchayat. And one of the striking factors for me was when we've already worked on about 15 lakes and partially revived some of them, was when water came to a particular tank and then it was full after many years. But then the question came as to who would benefit from the water. And it was clear that the people who would immediately benefit from the water were the farmers in the command area who were growing rice paddy. And this was roughly about 20% of the village itself. So what water was doing in this context as a hydrological unit was that it was becoming available in the tank. But in terms of water as a social unit, water was only benefiting those who had land. And this was very striking. If you did not own land, what did water actually mean to you? Because anyway, drinking water was being given by the government through the Jal Jeevan Mission. So this tank really had nothing much to do directly with drinking water. So water perhaps can create social inequities in spaces unknowingly for those who work on ecological restoration or just hydrological restoration of the function. This was very striking for me. And so therefore, the move that we are working with Arohana right now is to see how you can make sure that the availability of water is there for everybody, including and especially the landless. So some of the efforts that we have taken is to make sure that some water is reserved for pastoralists, for sheep and goat ruminants, that fishing rights are given to those who don't own land, and other methods by which the restoration of the lake ecosystem is done with the help of women who are given wage labor more than Narega, and therefore have a stake in the game in restoring the water ecosystem. So for me, social hydrology is the lens to view water, especially in the rural context, because water is what water does. Water is first a social good, then perhaps an ecological or environmental good, and lastly a physical or a hydrological good. Just wanted to set the stage because of the experience that one had in the rural context. In the urban context, as you have been working with, for me, post-COVID, the focus on One Health, that human health, animal health, and environmental health are all tied together, and this brings the concept of One Health, is fascinating. Because we in the water sector work on something called One Water, where we want to see all forms of water as one unit and plan and design and manage for societal needs and environmental needs. So One Health gives this opportunity. But I'm trying to approach it from a civil engineer's perspective, as a water perspective. And for me, the One Health aspect in an urban area comes from wastewater epidemiology, but also from the environmental health perspective. And I'll just sort of explore some of those ideas as we go along. And as I mentioned to you, One Water is a concept that we work on water, where fresh water, groundwater, and treated wastewater are all seen as one source of or one form of water, and that we plan accordingly. Because often in India, and especially in other countries also, in urban areas, we look at just a river or a reservoir as a source of water and we pipe it to our cities. We don't bother too much about groundwater. We don't bother too much about wastewater or rainwater. We've now started to pay attention to it. So One Health and One Water drives the sort of interest that one has on water. Environmental history is also very important because in the Bangalore context, 1876, 77, 78 were three landmark years where we had consecutive drought and then famine. And it's on record that about 90,000 people died in the city of Bangalore. And these were people who had also come in as migrants from Ballari, Kolar, and other districts which were drought affected and famine affected because food camps were being held in Bangalore. But the old Mysore kingdom lost 12.5 lakh people, which was 25% of the population. The glorious 1,000 tanks or lakes, which are often described by environmental romantics, as I would call them, were not enough to support a population of 1.8 lakhs. Now we are a city of 14.5 million, so therefore we ask ourselves the question, what is the role of these tanks and lakes? And I'll come along to explain what could possibly be one way of looking at the old tanks and lakes, but lots to learn from history and not be condemned to repeating it. That drought and famine caused the city rulers, after much wrangling, to go and make the river a reliable source of water. So a dam was built across the river Arkavati, about 20 kilometers away from the city, and technology kicked in using steam engines. Water was now pumped into the city, and the Arkavati or the Hesarghatta reservoir was seen as a much more reliable source of water, and actually it proved so. The population of Bangalore quickly expanded to consume the waters that were being drawn from the Arkavati, and therefore a race had begun where water supply would first go into a trough. There would be scarcity, as we are now experiencing over the last year. Then there would be adequate technological response. Water would come into the city, and the city's population would grow to consume the water so given to it. And this race continues even now. And so, is there a ceiling to this race? We don't know. And how do we plan for increasing consumption is one of the challenges that Bangalore City faces, as many do. Now, we are given three taps in our city. The three taps are pipe water supply, which is from the river Kaveri, far away, rainwater, which falls on the city, and treated used water, wastewater or sewage, which flows in our environs, which ideally should be picked up in sewage networks, taken to sewage treatment plants and treated. A lot of it is being done so, some of it is not being done so. But these are the three sources of water. And then the store of these waters are surface water, lakes, ponds, streams, and rivers, mostly lakes in the case of Bangalore. Soil moisture, an important part of the storage system where trees and plants of Bangalore can benefit from it, and groundwater, springs, shallow aquifers, and deep aquifers. Coastal cities have another tap, which is desalination. And then finally, there's a tap control, which is demand management, which could include metering, pricing, and leak reduction, and so on and so forth. And these are some of the ideas that need to be discussed and debated as to how we use demand management, because there's no unlimited water available. For us, the first tap has a huge footprint because it comes from 100 kilometers and 300 meters below. So there's an energy footprint. That energy footprint has climate emissions linked to it because 3.45 units of power is necessary to get 1,000 liters of water to the city. And if you take the capital cost, O&M cost, operations and maintenance cost, and a sinking fund, the cost of water is 95 rupees 1,000 liters, which is very expensive water. However, this water is given at subsidized prices to domestic consumption and non-domestic consumption in the case of Bangalore, which has its own repercussions. So therefore, the question one asks is water a human right? And we all agree that it's a human right. If so, is there a quantum that can be specified for that human right? What is that quantum, and when does it become an economic good, so that we capture the true value of water? And we capture the true value of water for the institution which is mandated to manage it, so that it is capable of collecting all the sewage, the wastewater that's generated by the consumption of this fresh water, treat it and release it to the environment in such a fashion that the environment is not polluted and can absorb it. Ideally, it should be done in such a fashion that it can be reused plentifully in the city itself. And we'll come to some examples where that happens. But the question to ask ourselves is, should water be priced? If so, how should it be charged? And how do we capture the human right to water? So therefore, as Subimal would talk later, we keep a close eye on the reservoirs of the Kaveri. Luckily for us, the Kaveri reservoir for Bangalore City has 4 dams upstream, and there's enough and more storage capacity there to meet the needs of the city. Ironically, the city only takes 11% of Karnataka's allocation of Kaveri waters and supports roughly 40 to 50% of Karnataka's population in the Kaveri basin, and generates roughly 50 to 60% of the GDP of the entire state. So the city, ironically, again, is one of the most efficient users of water. If efficiency were to be measured by the fact how much water supports population and how much water generates an economic demand, economic benefit, then the city is the most efficient user of water. And the city also is a non-consumptive user of water. It does not consume the water, it releases it back to the environment as used water, and therefore that can be treated and reused and recycled again, unlike agriculture, which is generally consumptive use of water. So therefore, that's the city in the context of a river basin. You mentioned already that India is one of the largest extractors of groundwater. In our city alone, there are more than 5 lakh bore wells from pumping approximately 800 million liters of water, not 600, 800 million liters of water per day. And borewells have gone to a depth of 1,800 feet. And the question again is, should it be regulated and how should the regulations kick in? Because we are very loosely regulated when it comes to groundwater. The other challenge is this, that if the city does not supply piped water to a particular citizen, a house or an apartment, can it have the right to stop that apartment from drilling a borewell or accessing water from a private water tanker who is taking it from groundwater? Is that not right to life itself? And so where do you trade between where borewell drilling should be allowed, how much water should be extracted? These legal frameworks are still very nascent and yet to be developed in the city. And ironically, again, we face flooding at the same time because the cities are badly designed in terms of road infrastructure, in terms of water infrastructure, and so therefore they cause floods. Should we not work together to make sure that floods then mitigate droughts? And so how do you do that is to conceptualize what's called rainwater harvesting, where now every plot is mandated to harvest 60 liters per square meter of roof area. That is to say, a 60 millimeter rainfall event should be harvested, either stored or recharged into the aquifer by every plot in the city, and about 30 liters per square meter for a paved area. Now, if we do this kind of a harvesting, then it's likely that we will be able to augment our groundwater, and it's likely that urban flooding will be mitigated to a large extent because 65% of the area of our city is actually private development and private plots, and there's a minimum depth of recharge of 3 meters. Now, this is based on the rainfall pattern, not just the monthly rainfall pattern, but also the daily rainfall pattern that the city faces, plus the intensity of rainfall too is taken into account in generating this rainwater harvesting bylaw. And there are at least 200,000 plots which are actually doing rainwater harvesting. Now, how do you expand it to cover the rest of the plots is the challenge before the city. Simple things like rooftop rainwater harvesting, which is then picked up in rain barrels, as you see here, and stored and reused when the need is there. The next point is the shallow aquifer management, which is now when you take aquifers, which are sponge-like structures below the ground, which store water and release it, and there are two components of the aquifer in Bangalore, the shallow unconfined aquifer, which is the weathered rock zone, the deep aquifers, which are deep bore wells, which go into hard rock terrain. Luckily, there's a lot of attention now being paid to shallow aquifers. That is, if you can imagine shallow aquifers as dug well driven, whereas deep aquifers are bore well driven, then you get a better idea of it. So how do we revive dug wells is some of the things that we pursue in the city of Bangalore. And so many dug wells are being cleaned because they had become dumps of garbage and waste and are brought into commons use. So these are common dug wells. These are not private dug wells. Many of them are commons. And as you see, the lady on the right, she's picking it up. When lake rejuvenation is happening in the city, thanks to public activism and the judiciary also stepping in, they have the benefit of recharging the shallow aquifer, and beautiful wells like this are also coming back to life thanks to us. And the well diggers, the well digging community, which is a traditional well digging community in Bangalore, which is now part of the solution of cleaning up wells and digging new recharge wells. So these beautiful wells have been revived, and they are now integrated as part of the network of the town municipal council. This well gives, for example, 1 lakh liters of water every day and is fed into the network. The other interesting component of this well revival is personified by this lady here, and this she made a very pertinent point when this well was revived. She said, if you put a pump or a motor in this well and you push it to the apartments, there will be unlimited demand and this well will go dry. Don't put a motor. We will go to the well with the pitcher of water. We need 4 pitchers a day. And this is representing 75 households in this community. And if each one of us takes just 4 pitchers every day, we're sure of water security. We're sure that the well will never go dry. And it's most likely that the apartment people will never come down to haul the water because they expect it in the tap. Whereas we know what the well water is and whether we can go there and draw the water or not. And so therefore, an idea of a demand management living within the ecological resource of the aquifer was represented by this woman, and we respected her. And we did not put the pump there. We put those 2 pulleys that you see there, and this well survived the drought of Bangalore throughout the year with only water at 10 feet. And the women said that the best thing about it was not just the quality of water, but the assurance that when they got back home from work, they would know that there would always be fresh water for them to have a bath, wash their clothes, or do whatever they wanted to do with the water there. That sense of water security in the commons. How do we then deal with it? Is it this drudgery, or is this choice is something that one debates endlessly, but we respect the women's choice there. How do you then manage it at a gated community level? So for example, this gated community has 360 plots. What would have happened is that each one of the plot would have drilled a bore well because they're not connected to the pipe network of the city. That means 360 straws into the same bottle of water. Each borewell would cost 2 lakh rupees. So you're talking about 7.2 crore rupees being invested in competitive demand for that groundwater, and pretty soon everything would have gone dry. How do you then turn this asset into a commons? What the Residents Association did, because it's legally mandated to do that, and that institution called the Residents Association was there, is they banned private borewells. They said we'll sink 3 common or community borewells. Whatever water we get from the aquifer, we'll share it. We will meter the water. We will price it so that nobody consumes more than 25,000 liters a month, but we'll make sure that all 360 of us recharge the ground. When they did that, when they did this kind of community filling and only 3 borewells taking the water out, when they did metering and pricing and they charged a heavy price after 25,000 liters a month, they were able to invest the monies in a wastewater treatment plant and supply treated wastewater to every household to reduce the load on the fresh water again. And they have in turn become, as these numbers will show at the bottom right, they are net positive in terms of water. Their groundwater table is rising. And over the last 12 years, they've just depended on 2 bore wells, which have water at 150 to 200 feet, whereas the rest of the neighborhood there has water at 1,000 to 1,200 feet. So it's possible that in a closed community, which has an institution and a legal framework, you could turn things around in terms of water sustainability if you plan well and if the residents turn water into commons, away from a private competitive good to a community good. So cooperative filling, not competitive drilling, is the word that one uses. How then does one move beyond this scale? We saw a well, we saw a house where rainwater harvesting is done, we saw a gated community. How do you move to a watershed and a lake? What is the role of lake in the city now? And so therefore, one of the examples which the city is now emulating over about 65 lakes, where it has finished work, and about 186 lakes where it's going to work on, is to pick a lake and treat it as a watershed entity, but also a wastewater recipient entity. I'll talk about Jakkur Lake, which is in the center. This is the lake. What I show you highlighted in circles is a sewage treatment plant. It's a 15 million liter per day sewage treatment plant upstream of the lake. This is the sewage treatment plant there, where most sewage should actually enter, though now still there's a lot of untreated wastewater coming to the lake. But ideally, all sewage flowing in the watershed of the lake should come to the sewage treatment plant. The sludge generated is used as a fertilizer by farmers because it does not have heavy metals or any pharmaceutical residues when tested. And the treated wastewater goes into a wetland to further polish the water, wetland being plants full of plants, which then polish the water and reduce potassium and phosphates, which is there in the water. Provides livelihoods for fishers who are now involved in the cleaning of the water as and when they come. From a livelihoods perspective, there's also fishing, there's also grass collection for cows which are there, and the lake allows these people to come in and take this grass, and the fish is of course part of a cooperative society, and people come up to pick up herbs and grass for their own kitchen. And as you see, the gentleman on the right, he's picking it up with fodder for his cows. Therefore, it becomes a living social entity which is driving livelihoods, and then it becomes an environmental entity where birds like the pelican, painted stork all come and become part of the ecosystem there. And finally, it becomes a functional entity because it recharges the aquifer to the tune of 7 million liters per day in the case of Jakkur, which fills the wells, and therefore this water then becomes available after treatment for potable use or without treatment for non-potable use. And so wells around the whole area in the particular aquifers can be revived. So can we reimagine our lakes to be this livelihood generators, ecology generators, as well as recipients of treated wastewater? And can we revive the ecosystem? It's a question that we ask ourselves. So this Jakkur model is now being replicated over 40 other lakes by the Bangalore Water Supply and Sewerage Board, treating wastewater going into these lakes. And because the sewage treatment plants are very well distributed in the city of Bangalore, and we have decentralized sewage treatment plants, we're also taking advantage of it not only to fill the lakes in Bangalore, but actually to push it and fill the lakes in the drought-affected districts of Kolar and Chikbalapur. This is done by the minor irrigation department, who treat it as a lift irrigation scheme, and you see that water is being pumped from the sewage treatment plants of Bangalore up to 120 kilometers. And that becomes the influence zone of the sewage treatment plants of Bangalore or the wastewater of Bangalore. You see these mapped there, up to 120 kilometers treated wastewater flows, and eventually 889 lakes in Kolar, Chikbalapur, Anikal, surrounding drought-prone districts will be filled by the treated wastewater of Bangalore. And so this is how the lakes look like now. They're now full throughout the year, 365 days a year. They cascade down and fill other lakes. The question is, can we improve treatment to make sure that it's not nutrient rich and that it's good enough for other activities, including swimming at a later stage? Right now, it's meant for recharging the aquifer and used for agriculture. So fisheries is being practiced in these lakes. 886 lakes will have fisheries there, providing employment, and groundwater is recharged, and farmers have water security. So the city acts as a water and fertilizer factory, pumping water to fill the lakes. Farmers have water security. In turn, the city has food security because whatever the farmers grow comes back to the city. So this is a concept of one water and one health, which needs monitoring from a water perspective and from a health perspective altogether. The last example that I wanted to show you is the small town of Devanahalli, where the international airport is located. And this also benefits from the treated wastewater transfer from Bangalore. What happened in Devanahalli town, population 45,000, is they depended on deep bore wells, 110 of them going to 1,200 feet, and the water was very saline. So therefore, they had to go to RO plants, reverse osmosis plants, for their drinking water, the other water being so saline that they found it difficult to use even for washing dishes or washing clothes. So what they did was they worked with NGOs, the town municipality, and determined what could be done with their lakes and the shallow aquifer. Calculations were done which showed that the shallow aquifer had enormous storage capacity, which was not being utilized because it was only rainwater fed. And so therefore, the treated wastewater which flows from Bangalore, as is shown in this figure, eventually reached the lake in Devanahalli, which was otherwise a bone dry lake. As you see in the figure on the right, for 14 years, there was no water in it. It's absolutely like a playground. And so the municipality worked at reviving the lake, desilted it, linked it to the catchment. And this is how the lake looks like now. It's filled with rainwater. And in case of summertime, treated wastewater, which is diluted at another lake, also comes to fill it. The lake is permanently full. And the well next to the lake was like what you see on the left before, full of garbage, cleaned up by the well digging community. Now it's full and with good clean water, which the earth has filtered from the lake. And a water treatment plant has been set up, which uses activated carbon filter, online fluorinator, and a UV system, ultraviolet filtration system, so that the water meets BIS 10500 drinking water quality, and the town gets roughly about 1 million liters per day shortly to supplement its water requirements. And when we look at the cost comparisons from a climate perspective, what we find is that when the aquifer is full and the groundwater table comes up, the requirement of energy, therefore the cost of water, and therefore the carbon emissions come down by a factor of 20. So 1/20th of the energy and cost is what you need. And the water cost in this town for drinking water quality is 1 rupee 54 for 1,000 liters. So the overall goal of the approach that we need to take for our cities and for our towns is social hydrology. And the city as a water and fertilizer factory, universal access, equity access, and justice as the fundamental goal. Everybody with the coverage for both water supply and sewerage, and water for life and livelihoods. If we think and imagine around this notion of use of water in a circular fashion, I think we will be able to perhaps address climate change a lot better than what we are doing it now. So thank you for the opportunity to speak, and I'll be happy to take questions later on.
Thanks, Vishwanath. That was actually very inspiring, all that's been done. I think there's a question in the chat box, which maybe you can reply to by text, or we can come back to that when you want to. Let me just move on to Subimal. And let me introduce him. So Subimal is an institute chair professor in the Department of Civil Engineering and convener of the interdisciplinary program in climate studies at the IIT in Bombay. He earned his BE from Jadavpur University, followed by an ME and PhD from the Indian Institute of Science, Bangalore, which is my own alma mater. His research focuses on hydroclimatology and hydrology. It covers areas such as climate change impacts, regional climate modeling, land-atmosphere interactions, Indian monsoon dynamics, and hydroclimatic extremes. He has a number of awards, including the Shanti Swarup Bhatnagar Prize in 2019, the Alexander von Humboldt Medal from the European Geosciences Union in 2024. He's a fellow of a number of academies, including the Indian National Academy of Engineering and the National Academy of Science. But he also served as the lead author for the IPCC 6th Assessment Report, AR6, Working Group 1. What he speaks about is making early warning usable by different sectors, applications to disasters, and to agriculture. Go ahead, Subimal.
Thank you. Thanks for this wonderful opportunity, and it was really nice, listening to the previous presentation, which is specifically on really doing some work which is related to climate adaptation and also designing sustainable planning. So I'll be talking mostly on early warning system, which is more like a non-structural measure for many of the disaster that's happening, as well as for agricultural water management. Of course, more related to water. So when you're talking about disasters here, I'll be only talking about water-related disaster, which is about flooding and agricultural water management. And I'd like to mention, of course, Professor Gautam was mentioning that today in this panel discussion, we could not have a women panelists, but I'd like to mention the works which I'm showing today. All of them were done, initiated, and led by women scientists. For example, the agricultural water management work was initiated by one of our women students, Adrija Roy, and the major part of urban flooding and early warning for water-related disasters were initiated by two of my women students, Shravani Tripathi and Pooja Tripathi, and after that, a lot of other students started joining, and all of them started working. So all these works were initiated by women students. So yeah, that's something I'd like to mention specifically. And the other thing also, this is the work which were done by student, faculty, staff together. Because we believe that if you're talking about early warning system and climate adaptation, it needs a collective effort rather than an individual effort, even in academia also. So this is all done by them, and I'm just representing their work on their behalf. Uh, so, yeah. So, I'll just briefly tell a little bit about our climate studies at IIT Bombay, which is an interdisciplinary center, and we like the Climate and Sustainability Center of Ashoka University. Our center also works with faculty members from various other departments. For example, we have around 30 faculty members from 12 different departments, including different engineering and technology department, humanities, economics, and environmental science. And also we have 7 core faculty members who are specifically working on climate studies. And we would also work on different areas of science adaptation and mitigation. We focus more on scientific and technical sides, but also we have social scientists. So we work on climate variability trends, climate change, and we work on designing better climate services and solutions. Because we are in technological institute, our one of the goal is to develop a better better climate services and solutions to make the sectors weather smart and climate ready. And we design early warning system for day-to-day management for different sectors. And when we go to policy and decision horizon, so we talk about decadal scale prediction, and that's the way we work. And our final plan is to really finally develop some of the risk maps. So, how did climate services help our country? Because this is one of the area I feel that which was kind of neglected, in the sense like we never, I mean, we normally do not appreciate much the climate service providers who are actually doing, I mean, a silent revolution is actually taking place in our country in terms of science, which never got much of attention. For example, I'll go back to 1999, there was a super cyclone in Orissa. Many of us know about it. So highest wind speed was 260 km per hour. And as per government records, there were 15,000 deaths. The number of real death was probably more than that. And it was in 25th October 1999. I remember I just joined Jadavpur University for B for during that time, and I know a kind of thing what has happened. And then 2020 we have super cyclone Amphan, exactly same wind speed, but total fatalities was 118, and that too because many of them didn't really follow the weather forecast. And damage was of course there, but that's the power of science. The power of science resulted into reduction of death in 20 years from 15,000 to around 100. And that power of science came through the development of better climate science, understanding of Indian meteorology, I mean meteorology over this Indian subcontinent in a better way, and then incorporating them in early warning system, and not only stopping at early warning system, and then with that disaster, I mean connecting this early warning system to disaster mitigation planning. And once that is done, Orissa could showed that, and or maybe the East Coast states showed that, they could reduce the number of deaths like this. So that's the power of science. That's a silent revolution in science, which is saving our country, which is saving our people, and we must appreciate their efforts. So now one of the, when it comes to water, I mean, this is one of the flow chart or some sort of a flow diagram, which I show in most of my talk, because I feel this is very important to understand what exactly is happening. So we know that our population is growing. Of course, number of people is increasing. So we have to produce more crop for the food security. So our agriculture has to intensify. When the agriculture needs to intensify, we need more water. And at the same time, temperature is increasing, we need further more water. Now, so water demand is increasing, but at the same time, what has happened? Since 1950, there has been weakening of monsoon, but from 2000, scientists have started claiming that there hasn't been a revival of monsoon, but in terms of extreme, so it's not helping. So your demand is increasing, availability is reducing. So you have to rely on irrigation. Now, when you are doing this irrigation, there is absolutely uncontrolled irrigation, and often in the last few decades, because of certain government decisions in terms of subsidies, etc., what has happened? Irrigation have been uncontrolled, and that resulted into groundwater depletion. And what is happening is, because of this groundwater depletion, for extracting the same amount of water, if you are going from 1 year to next year, your energy requirement, your irrigation cost is increasing because groundwater is depleting. So essentially, we end up with more irrigation cost, and finally, it will finally increase the crop price, because it has to get reflected in terms of crop price, and then it will create problem in food security. So what is happening is that you are trying to solve a food security problem, you are doing a lot of things, and finally you are going back again to a food security problem. So it's not really helping, and I believe this is one of the grand challenge for us, how to really have a proper food and water security. So one of the things we are trying to do is that we are thinking that, are we really growing the correct crop? Or if there is a little bit of change, will that really help or not? So we are working with a group, inside IIT Bombay, as well as with Columbia University, Professor Uddeep Fries. So we are actually working together, and we are trying to understand over the Indo-Gangetic basin. Let's say if we develop some sort of an optimization, of course, I'm not going to details of the mathematics here, but if we can maximize the total kilocalorie production, maximize farmers' profit, we develop some way to compute farmers' profit, minimize water use, of course with a constraint that will not change the total crop area, but we can just do a switching of cereal crops. Can we really help? Can we really end up with a better scenario? So we published this work in Nature Water, so we wanted to do this. So the first question we tried to address here is that, are our agricultural crop practices really sustainable or not? So if you consider trend of annual rainfall, you'll see that there has been a reduction in rainfall. You can see specifically over the West Uttar Pradesh region, there has been a reduction in rainfall. Now, if you look at the water consumption over the Indo-Gangetic basin, specifically over these three states of West Bengal, Bihar, and Uttar Pradesh, you will see that water consumption by cereal is around 50%, 30% by other crops, and 20% is by other crops, and 30% is by livestock, domestic and industrial. So 50% is our cereal crops. So let us talk about them. So if you consider the water consumption by those crops, yes, it has increased. But if you look at the total kilocalorie production per unit water consumption, it has not really improved. And you can see some of the district, it has actually reduced. So that means we are becoming less efficient. And if you look at the groundwater depletion, this is from the Central Groundwater Board data. Yes, groundwater is depleting over these regions. And if you do some simulation, things are quite clear. Groundwater abstraction is increasing, and so recharge minus abstraction is decreasing. So there is a groundwater depletion. And if you do theoretically the energy consumption for irrigation because of this depletion, that is also increasing. So we are in a bad state. So what we did some kind of optimization. Here the idea is not just replace one crop by another, but what we are trying to do is that, at some of the districts, if we can change the fraction of crops, let's say change 100% rice to 50% rice and 50% other crops and so on. If we do that sort of things, will that help in a better condition or not? We wanted to understand the optimum values. Of course, not in those regions where millet is not possible. Of course, that some of these considerations we wanted to take. And what we have found is that yes, there is a need to switch the crops, and it shows that it not only improves water requirement, or it doesn't only result into a better water scenario, but also in terms of better profit, because some of the crops are really climate resilient. paddy is not a climate resilient crop. So if there is a monsoon failure, some of the crops may fail, but some of the climate resilient crop may work in better way. But of course, we need to create more demand for that. And some of these crops are actually nutritious crops, so finally it will result into a better nutrition. But of course, it needs we need a social scientist to really convince farmers that this region you can at least grow some other crops and see that it may improve the condition. And of course, we have to create demand, which is a long journey, but the technical part of this, at least we could do, and we are thinking in what way we can do it better. The other thing also we wanted this work. This work was started. The previous work was led by Ruparati Chakraborty, again a women's student. This one started with Adrija Roy, another women student. So the idea was that when Adrija joined, we started developing some relationship with some of the farmers over Nasik. So they were kind of rich farmers because Nasik there are vineyards, and at the same time there are very rich grape farmers there. So we started talking to them. It was under Shayadri farm, so we started talking to them, and they said they were very happy because they have soil moisture sensors which are installed at their farms, and they were doing some kind of a bucket model, water bucket model, and once in a week they normally irrigate, and they calculate the water requirement through some bucket model. And they said that they are doing an optimum. I mean, they are using water in an optimum way, so that they are not wasting water. So we just asked them out of curiosity that why don't you use weather forecast? They said weather forecast, of course, they come for district and so on, but we don't find it's really very useful for our farms. And then we said, can we get an opportunity to understand your method and then start adding the weather forecast component into it in a slightly different way, and try to see that if that really works or not. So while working with them, so before that, I'd like to mention that there are different ways the weather forecast comes. At weather scale, it's 1 to 3 days. Then it comes medium range, which is also we consider under weather forecast, which is 3 to 7 days. Then it comes extended range predictions, where day to day is not important, but weekly forecast is important, which we call it S2S forecast or subseasonal to seasonal forecast. Then comes seasonal predictions. And then, of course, decadal to multi-decadal predictions, which is for policy decisions. So we are mostly interested in, first we started talking about weather forecast. Can we go up to 7 days? Because they were interested in 7 days because they normally irrigate once in 7 days. So then Adrija started talking to them, understanding their logic of irrigation, and she developed the mathematical formulation for the same, of course, taking their bucket model and so on. Then what we did is that we are not really connecting weather forecast to that sort of model, because the problem was that weather forecasts also have their own uncertainty and they have their own errors. So if you don't address these problems properly, then farmers will not find it very useful. So what we did, we considered the past forecast. And here I'd like to mention that if you really want people to use early warning system or weather forecast, the most important part for any meteorological organization is that they have to provide the past 10 years forecast or 15 years forecast, because without that, people will not believe that the forecast is really good or not. So the same thing really happens even if you are designing any kind of early warning system. So what we did, we took past 5-6 years of forecast by the same model, which we call reforecast, and then given a forecast, we tried to generate a rainfall distribution, and we develop a stochastic optimization. So essentially considering the uncertainty. So in a very simple way, I can tell that we are considering the uncertainty in the forecast. We somehow get it reflected into the stochastic optimization model, which tries to reduce the water use, but at the same time, the yield should be maintained. We took care that the yield should be maintained. We optimized that. And then we found that it's actually working. 10 to 30% of water saving is possible. In fact, those farmers were also kind of very surprised, saying that, yes, weather forecasts really add value, which is, let's say, 50-kilometer weather forecast, but we are downscaling it at a farm scale, even if it's adding value, which was a surprise for them. Even it is a surprise from many of the IMD scientists when we showed this model to them. So this really works. Of course, we patented it, we published a lot of paper on this, but what's important is that, yes, it adds value. And the farmers immediately said, okay, we can understand that, weather forecast really adds value. But what is important is that we need to understand how much water is needed 2 weeks in advance, because we have to really make arrangement for the water. Then we said, okay, we can try extended range prediction. So we did try extended range predictions. And then with that also, we showed that, yeah, it is possible to tell that this much water is needed 2 weeks in advance. And that is quite a good estimate. So they are also happy with that. So we did a series of work on this. But one of the thing I'd like to mention, what we have found is that, of course, with those 2-3 farmers, it was easy. But if you have to upscale it over a large region, affordability is a major problem. What is the problem? The problem is that good soil moisture sensors are very costly, and most farmers cannot really afford them. So what is the solution? Solution is satellite image. But if you look at it, so maybe I'll just show you. If you're considering a proper satellite footprint, so you can see these are the farm locations. These small spots are the farm locations. And if you're considering the satellite footprint, the raw satellite data, which is of 25 kilometer for soil moisture, which is even at surface level, not even at root zone level. And if they use some model, we further get a 9-kilometer resolution, which is even very coarse compared to these points. Now, if you're considering weather forecast, this is the resolution. You can see this is a big box is one grid, and we are talking about this location. So essentially, it's very challenging. So what we did for soil moisture, we did some downscaling with some AIML and physics approach together, and then we used them. And then what we did, we also used the weather forecast, downscale weather forecast, and we tried to develop a ready set go strategy. That means 2 weeks in advance, it will tell, okay, this much water is needed. And then when at the time of irrigation, it will tell, okay, look, this much water you apply, then for next 7 days, you don't have to worry. And we tried to test it with at some locations, assuming that that location does not have a sensor, and we applied this optimization and found out that if it is really working or not. We found it's really good, working well. So we are kind of very happy with our Nashik experience, that yes, weather forecast, the scientific development that has happened in terms of weather forecasting or remote sensing, they are really adding value at a farm scale. Only thing is that we have to think a little bit out of the box, and we have to design in such a way so that the farmers also find it useful and they can also trust on it. So that means we need to go for co-development. We need to go for participatory approach. So once it is there at Nashik, so we thought that let us try at some other location. And then at IIT Bombay, we are also thinking of developing some sort of a living lab where, in fact, I'd like to mention that we're starting this year, we're starting a master's program, MTech program in climate and sustainability. So we thought that we should set up some living lab where the students will get an understanding about real life, in what way climate services or different climate solutions can be applied, and they can experiment while working with people. So we picked up one of the district which is named Satara, close to Mumbai, not very close, around 200 kilometer, 250 kilometer from Mumbai. This Satara is very interesting district, and there is a reason for picking up this. Those who stay in Maharashtra, probably they know that Mahabaleshwar is a fantastic place in Satara, which receives around 6,000 mm of rain, which is very high rainfall, and is a beautiful place in monsoon. And in Satara district, there was only one IMD station. So of course, last year we could convince IMD to set up another weather station, but there was only one weather station, which was at Mahabaleshwar. So as per government record, Satara receives 6,000 mm of rainfall per season. Now in the Satara, there are 3 layers of Western Ghat mountain that goes. So what happens? If you cross this Western Ghats, there are 2 talukas. These are the 2 talukas which are Man and Khatao. And these 2 talukas receive, you can see that Man taluka, if you go from Western, you can see that 7,000, 8,000 of rain over Mahabaleshwar. Now if you go to central region, that means you are crossing Western Ghats, it starts reducing. It reaches around 1,000. Now if you go to Man, it is below 500. So Man and Khatao are the 2 districts which are essentially water deficit talukas in a water surplus district. So, and they are suffering like anything. One of the bad problem which has happened over this region is that in 1980s, 1990s, there were few farmers, because of some good rain episodes, they started growing grapes and they got some good profit, and they continued that. Then what happened? Then they started facing a lot of crop losses. And once they started facing, the younger generation from those villages, one of the villages, Kaledhan village in Satara, from those villages, the able young male population has moved or migrated to cities like Mumbai and Pune. So there are old people who are living, and sometimes women and children are living there, and they are suffering. They are trying to do little bit of agricultural activities at small farms, and still big farms are with some of the rich farmers who are still extracting a lot of groundwater depleting badly, and others are unable to use neither surface water nor groundwater. So it's in a very sad scenario. So we thought that, let us, if we have to apply some sort of things, we need to apply here. So we are still working. We have started. I mean, we have just started. We have set up our own automatic weather stations. We are setting up lot of soil moisture sensors. You can see there are many grape farms also here, which is very surprising. But in a water deficit region, there are a lot of grape farms. So idea here is that, and also we are trying to get past cropping information. Of course, more than 2-3 years we are unable to get. The idea here is that can you really digitize the entire village with farm with small farm locations and all details. So that's what we are now trying to do. A group of students visited, and they keep on visiting, and they are trying to get this information. The idea is very simple. First, we have to go for better monitoring. Then we have to go modeling and management. And the idea here is that we'll give a better irrigation advisory. And at the same time, considering decadal predictions and past decades water budget, will suggest that, yeah, which crop can be a better crop for them. So whatever I have shown, whatever technical work which we have done, we thought that let us apply over these villages. Of course, we will not force the farmers, but we can just demonstrate them, and if some of them use it, we'll see that if that is really improving the scenario. So that's one of the things which we are planning. The second thing, which is a bit interesting because it's about Mumbai flood monitoring and forecasting. So this whole work started 2.5 years back with support from one of the insurance company, HDFC Argo. So what we Mumbai, all of us know that this is very high rainfall, and there is a huge spatial variability of rainfall. For example, if you are considering 26 June 2005 rainfall, when Mumbai Santa Cruz received 900 mm rain in 24 hours and Colaba received only 84 mm. So there is a lot of spatial variability. This is high rainfall. It's a very low lying area. So a lot of flooding happens over this region. But the unfortunate part is that there is no real-time monitoring of flood. For example, if you in Mumbai, if you are at IIT Bombay and if you want to go to Dadar on a heavy rain day, you do not know if at that point if Dadar is flooded or not. That sort of information is not available on real time. The second thing is that, of course, there is a good forecast system by IMD and other meteorological organizations, but still they come little late. Sometimes there are bias in terms of forecast. Sometimes what happens is that probably the IMD forecast comes little late, and when they come, by that time the flooding started. For example, last 25 September of last monsoon year, suddenly in the evening heavy rain started, and because heavy rain started, many of the regions got flooded, and that resulted into a lot of problems to the people. So we thought that can we really come up with some sort of a system which will be run by the citizen for the citizen. So it will be run by Mumbaikars for Mumbaikars for a better flood monitoring and forecasting system. That was the idea. So when we started looking at it, we started looking at the rainfall patterns. So what we found is that it's very simple. There is no rocket science, nothing is there. It's pretty simple. What we found is that if you look at Mumbai rainfall, we found that if you look at maximum rainfall, there is a horseshoe pattern. So this is the region which receives very high rainfall. Why is it happening? So if you look at the orography, you'll find that this is the hilly region of Mumbai, and this brown part is the low-lying area. So because of orographic pattern, this low-lying areas receive very high rainfall. And because it's low-lying, so heavy rainfall, low-lying, further it results into flooding. So these are essentially the flooding hotspots of Mumbai. So what we thought is that, okay, we thought that, of course, there is no proper monitoring. BMC, of course, from last year started some monitoring, but this data is not available to Mumbaikar, to the best of my knowledge, because I don't see them in their website. So what we thought is that, 2 years back, we thought that, okay, we'll start crowdsourcing the data. And that time, of course, Twitter was open, so we could download at any point of time. We started with Twitter. So we started with Twitter, and we wanted to verify the Twitter data with some of the trained volunteers. So we talked to some of the NGOs and then we trained some of the volunteers and we matched them and we tried to find out if Twitter is, I mean, there are a lot of tweets about Mumbai and Mumbai flooding. Are they giving correct information or not? So for example, July 5, 2022, when you looked at it, you can see this again I'm showing that this is the high elevation region, this is the low elevation region. Now if you look at the tweet, we found that this is the region which received maximum number of tweets in terms of flooding. Now if you look at the automatic weather station data, you can see that this is the region which received very high rain. And if when we talk to the volunteers, trained volunteers, they are also reporting this is the region which has the highest number of reporting of flooding. So essentially it shows that all of them are matching. So crowdsourced information is a major source and they are providing very good information. This shows. Then we thought that, what we did also, we have taken historical tweets 2017 to 2022. And of course, we use some kind of a natural language processing method. And there we tried to understand that, whether the tweets can be validated. And we found that, and of course, there was no proper reporting. So what we tried to do is that we tried to check with newspaper. And what we have found is that 66% of the tweets we could validate straight away with newspaper. So it shows that it's a very useful information. Now, so some information about flood monitoring we can get from tweet. The other thing is that can we get them directly? But before that, also what we did is that we tried to improve the daily forecast because of course we have a proper forecast. We have some forecasting system. We thought that can we further downscale it at hyper local level at those specific stations. So I'd like to mention that Mumbai has a lot of stations, automatic weather station. You can say that within that city we have so many stations, around 60 automatic weather stations are there. So we thought that can we really make the forecast at a station level. So what we did is that, of course, we took the gridded global forecast system data is a global model data, and we have started using some simple convolution neural network and tried to with some hyperparameter tuning, and we tried to find out if it is working well or not. We found it's working well, but it's failing for extremes, so it's of no use. So even if a model performance is getting improved, but if it is not working for extremes, it is not doing well. Then what we did, we started focusing on extremes. We have taken the train structure. We did further hyper parameter tuning, which is known as transfer learning. We did some transfer learning and then tried to see that if it is working well or not. And then we found suddenly the extreme forecast system is working well. So for example, this is the 95th percentile monsoon rainfall. This is global forecast system heat rate. You can see that heat rate is not that good for the global model. There are reasons because it's a coastal city and there's an urban regions and models normally fail at a very high resolution at coastal city and so on, and this is what is happening. So when we started using some kind of a AI/ML, it starts improving a bit. But when we are considering transfer learning, you can see that for extreme rainfall, it increases like anything. It 60 to 70% of the extreme rain, we could do it properly. And if it talks about false alarm, you can see that the false alarm was quite high initially with the global forecast system, but when we changed it to the AI/ML, of course, it has reduced a bit, not significantly, but when we consider the transfer learning, this is the model we are finally using in our forecast. It reduced quite a lot. Now what we did, we have developed a web portal. So last year we developed this web portal and also a very similar app for Mumbaikars. Around more than 2.5 lakhs app download took place so that people started following it. So I'll show you some glimpse of this web portal and app which was developed by our students. So this is some sort of a, you can pick up any station, and if you pick up the stations, what you'll see here is that it will tell you the observed rainfall over the full day at every hour. And it will also tell that what was the rainfall forecast and what are the next 3 days rainfall forecast. And these are the past 3 days forecast. And also it will tell that in the entire season, how did we perform? Because that will give people some confidence that yes, it is really working well or not. Then only people use, otherwise people should not. And then we have also, what we did is that we have installed some of the sensors at different locations and we are making all data available so that people can see. As I said that this will be by citizen for citizen. So this shows all the sensors. This is not really on a very extreme day, so you cannot see these high values, but yeah, so this essentially there are sensors which shows. Then what we did, we have designed some crowdsourced information thing. So what is being done is that, let's say people are saying that, let's say someone is saying that some region is waterlogged. What he has to do, he or she has to do is that he or she has to pick up the current location. I mean, just use my current location, it will take the location. Then he or she has to give his or her height and give some qualitative information. Then immediately it will be reflected on this map. So let's say now if I want to go from here to here, and if I see a lot of 2 feet kind of waterlogging information, if I see over this region, I'll be a bit careful and I'll make a decision whether to really go or not on a specific monsoon day. So that sort of information we can start getting. Sorry, yeah. So this is something which we develop, and we thought that this kind of information will be helpful for the people. Now this year our plan is to start nowcasting. So for next 3 hours, what will happen? We'll do that. And also, so this is something also we did, which I'd like to show, is that these are essentially the railway stations of Mumbai. We know Mumbai local train service is very important. So we wanted to give information how many of the stations are really under stress because of high rainfall and how many of them are not so much. So that sort of information we'd like to give in terms of real-time rainfall information over the stations, and the tweet analysis. Whatever tweet is getting available, we are doing some sentiment analysis, and we are trying to say that what negative sentiments mean, people are not really happy and people are complaining about something like, these are the regions which are waterlogged, or there are some inconvenience or some sort of a transport problem because of waterlogging and so on. And this year our plan is to go for a nowcasting, so that for next 3 to 4 hours we'll provide every 15 minutes what will be the rainfall condition. Our plan is to also predict. I'm not sure how much it will be successful, but our plan is to also provide the information of local train delay because of heavy rainfall and flooding. So we'll forecast for next 3 hours how much delay there will be there in local local train, and that sort of information, as well as flooding information. So we have started running a flood model as well. So these are some of the things which our students have been doing. So last year, as I said, that last year it was operational, and a lot of people have used our thing, and except this one event, all other events were correctly forecasted by our app. And in fact, for 25th September, where most of the meteorological organizations or meteorological forecast system could not forecast, we could forecast one day earlier that there is chances of very high rainfall, and it actually happened. And those who are actually following our forecast, they thanked us. And you can see that a lot of people tweeted about our forecast. A lot of newspaper also have reported that it is working well and it is actually helping people. Thanks to it is not my work. This is really actually there is a collective work of all our student, staff, faculty, and so on. So this is about the team who have worked, and thank you for your attention. I hope I have not taken much time. Yeah.
Thanks so
Go
much.
stop at time. Yeah. Thanks. Thank you.
Thank you. It's fascinating stuff. We can come back and discuss it I have various questions about the technical details. But let's move on to the last of the talks, and that's by Shripad Dharmadhikari. He's an activist and researcher and the founder coordinator of Manthan Adhyayan Kendra, which is a center that focuses on analytical and advocacy work in the water and energy sectors. So he's been looking at the intersection of water, energy, and environment development through the lens of equity, justice, sustainability, and efficacy. And he's been working on water policy and programs, river and water resource management, especially using environment flows approach, dams, hydropower, irrigation, privatization, commodification in water, impacts of coal on water, and inland navigation. So he's an engineer. He's from IIT Bombay and was an activist for many years with the Narmada Bachao Andolan. He maintains close links with grassroots groups and campaigns, and is attentive to the struggles of people affected by various developmental interventions, and tries to learn from them and to support their efforts to the extent possible through his work. He writes extensively on issues that relate to both the environment and to development and the joint context. He's right now taking a break from day-to-day responsibilities to think more reflectively about writing. And he'll speak about we need to talk about water, especially the things less talked about, which is a wonderful title. Go ahead, Shripad.
Thank you, Gautam. And Thank you, Dr. Subimal and Vishwanath, for those very, very inspiring presentations. I don't have any slides or a PowerPoint presentation, so I will just be sharing my thoughts without those slides. As Gautam has mentioned, my presentation is titled, the event itself is titled, We Need to Talk About Water. And what I wanted to share was that, yes, we need to talk about water, but there are also several things which are not so talked about. So let us talk about some of the things which are less talked about. So that's the my presentation or my talk is going to be about. But though it is about things less talked about, actually, I'm going to start with something that is really talked about a lot when we talk about water. Or more accurately, I will say about rivers. Because a lot of my work has been around rivers, my talk will also be talking about rivers. But in general, what the kind of points that I want to make about rivers do apply to the entire water sector, to other water bodies, and to the way we are managing the entire water sector. But I will be talking about rivers. So when we see a river, and especially if, when a river is there and there is water flowing in the river, one of the most often heard statements or talked about statement is, "Oh, this water is going waste to the sea." Now, this is such a common refrain, especially if you hear policymakers, water planners, the water bureaucracy, engineers who are managing water. This is a very, very common refrain, and it's not about today. I've been tracking, water studies and the history of water management in this country, and right from the first 5-year plan, or even going before that, to today, this is one of the most common refrains that one hears. It is so common and so commonly, it is so entrenched in the thinking that I would say that it is one of the most important characters of the dominant paradigm of water management today in the country. Now, when you say this thinking, that any water that flows down the river and into the sea without being used is a waste. And use here actually, of course, refers to use by humans, right? So this notion that water that is flowing into the sea is a waste betrays two parts of the thinking. One, of course, is the whole thinking is anthropocentric, because essentially when we talk about water and water management and all this, it's essentially just focused around human beings. That is why if it is not used by humans, then it is a waste. That is the first thing which is an important point. And second, of course, is that it betrays an ignorance about the ecological functions that flowing water is performing, or even in other ways, it is also creating several livelihoods and all that. This is obvious, but there is another part of it which is not so obvious. Behind this statement, there is another part of it which is not so obvious, and that is often these kind of statements are made without even talking about needs. Yes, the water is going waste, so we need to extract it. But for what? That is never talked about. And behind this is a kind of thinking which says that actually our water needs of India as a country are so vast that we don't need to say, whatever amount of water is there, we can extract it and it will be needed, it will be used. Now, this is supported, of course, by talking about our large population and also some statistics which have also been mentioned earlier that I think, Gautam, you mentioned it, that we have 18% of the global population, but we have only about 4% of the water resources of the world. Now, these are valid, very important points. I don't want to deny that, or I don't want to even demean that. It's an important thing. But to translate this, to then say that our water needs are virtually unlimited, I think this is a serious problem. And it is a problem because of two things. First, of course, once you say that our needs are virtually unlimited, then it's an admission saying that we will never be able to meet our needs. Now, this is a very problematic approach or thinking, right? Because it virtually is an admission that we will never be able to meet all our needs. The second thing is, it is also saying that there is no way we can leave any water in its natural state in any water body, because we need all the water that we can extract from these water bodies. That is why we really need to talk about these so-called needs or demands on water. Now, whenever water, we talk about water planning, water resource planning, water management in this country, much of the discussion overwhelmingly is on the supply side. How to make more and more amount of water available, all right? But really no good planning can be done unless we talk about the demand. And that, unfortunately, is something that is not much talked about. And so I would say that this is one of the most important things that we need to talk about when we talk about water. Our demands. We need to ask questions. How much water do we really need? For what kind of uses? Of course, food security, drinking water, these are the answers. But can we take these answers at face value? Yes, food security, but then does this mean that food security can be met only by growing this one particular crop? Dr. Subhimal brought in that whole issue of cropping pattern. Very, very important question. So we need to ask, how much water do we need for what uses? Can we take these uses which are claimed as at face value? These uses which are mentioned for our water needs, are they all at the same level of priority? Can some of the priorities be different? Do we need to meet each of these uses by only extracting water? What are the kind of uses that we can make through non-consumptive use of water? What are the uses of water, or what are our needs that will degrade the quality of water? And what are those that will not degrade the quality of water? So these are the kind of questions we need to ask. Are there some of these so-called demands or uses which are mentioned that don't make any sense? And maybe we can say, yes, no, these are not valid uses. I think it is very, very important to ask these questions, because unless we ask these questions, we will not be able to really get a good understanding of what are our real needs. This kind of engagement is largely missing in the whole water discourse in a major way. A kind of a comprehensive national level assessment of what are our realistic water demands, sector-wise, basin-wise. This was last done for the country in 1999. This was the National Commission for Integrated Water Resource Development, and it gave its report in 1999. After that, there's virtually nothing. Yes, there have been some smaller efforts at some state level or some specific basin levels. Some independent organizations have done some efforts like this. But otherwise, virtually, this has not been talked about. And as we know, from 1999 to today, there have been many, many changes which have a large effect on water demand, what our water demand can be and water availability can be. Climate change, of course, is one very big factor, but changing nature of industrialization, changing industrial water demands, new demands, for example, green hydrogen, or a different understanding that we have, a different appreciation of the ecological and environmental importance of environment and ecology. So many things have changed. Better technology is available for us to be able to make more efficient needs. So we really need to look at the demands both from a critical examination of that and also from the changing situations. And I think this is something which is not being discussed. So I will say we need to talk about water. Let us talk about our water needs and water demands. But this kind of just a qualitative or even a qualitative, quantitative analysis is not sufficient. There is one more very, very important aspect. Whose demands are we talking about? Yes, there is a lot of demand for water, but demand for whom? And whose demands? In particular, there are, society is not homogeneous. There are different sections in society. Which sections' demands are being prioritized? Which sections' demands are being sidelined? Now, this is, of course, the issue of equity. And in a comparative way, equity is at least more talked about, definitely. But still, I think there is much, much more that needs to be talked about, even within the parameter of equity. Equity, some talk which is there essentially has been around some of the things like, for example, say, the infrastructure projects which are created for water available for enhancing water availability or meeting our water demands. They create inequitable impacts. For example, dams. My personal experience where I've been working on dams and displacement. Dams which provide water to farmers for irrigation displace thousands of people who lose their lives and livelihoods. Now, this kind of thing has been talked about a fair bit, and I think mainly because of the efforts of the struggles which have been there, the dam affected people's struggles. But even within these kind of things, there are things which are still not fully understood. The kinds of inequity. For example, let's come to take example of dams again. The dams which store water to provide water and irrigation to the farmers actually can destroy the livelihoods of fisher people downstream because they dry up the rivers downstream, as has happened in the Sardar Sarovar project on the Narmada River, for example. This is not so well understood and talked about. Or, for example, we have now a big program which has been launched by the government of India in the last 10 years for inland navigation under the National Inland Waterways Program, where you want to have big vessels in our rivers for transport of goods and commodities. But these kind of vessels will actually, again, impact a lot of the fishing community because they deprive the fisher people of the access to some of the best fishing places in the rivers because those are now earmarked for navigation channels. So these are the kind of examples which are even within the infrastructure projects and all, these are not understood so well. Beyond that, I think there are also more nuanced aspects of equity which we need to understand. For example, again, coming to irrigation and dams. Typically, irrigation project, a large dam-based irrigation project would provide that water to the farmers through gravity. So the water would go wherever gravity takes it, and the water would be provided to farmers depending upon how much land they have. So all the land of the farmers in the initial reaches would be irrigated, and so on, so forth, till the water reaches the end and it finishes. But there are very strong arguments which say that instead of this, let us distribute the water in a much better way. Let's distribute it in a wider way. So that, say, for example, we provide a certain quantity of water to each farmer. And so that we can reach more people. Though some of the individual farmers may get less water than what they were getting earlier. This is the principle of equity. There have been, there has been work which goes even beyond that. I particularly want to mention the work of the late Vilasrao Salunke, the very well-known, renowned water and social activist based near Pune, who advocated that irrigation water should be even given to landless. And he actually set up those systems to show how that created a lot of benefit. And I'm actually very happy that one of the things which Vishwanath mentioned in his presentation was the same very fact that, unless you talk about even from a water tank which is designed for irrigation, you talk about how the landless can benefit. So there are all these nuances around equity. And it's not just one or two small things. There are also people talking about this on a large scale. For example, in 2013, there was a report presented to the Maharashtra government. Maharashtra government had set up a committee for the balanced regional development of the state. And it was headed by Dr. Vijay Kelkar, who was the chairperson of the 13th Finance Commission, retired as Secretary to the Government of India. He had headed that committee. One of the most important suggestions, to my mind, that he made was that let us give protective irrigation as a right to every farmer in the state first. And then over and above that, if any water is left, then we can give irrigation beyond that. So these kind of, these are only some examples which are there. Again, I think, another example which Vishwanath gave again struck me as an example of something similar, where that well which was there, the local lady came and said that instead of giving it by pump to, some of the apartments, if you give it and we withdraw only by buckets, then, more people can benefit. So I think this whole issue of equity has many dimensions, and it is less talked about. So I would say that we need to talk about equity in the water management, and talk about many more innovative and even radical ideas as far as equity is concerned. So I think that is one thing which is largely missing in the whole dialogue and discourse around water sector, and we definitely need to talk about it in much greater detail, much greater depth, and much greater innovation. Of course, what we have talked about, the needs and even equity. So far, we have talked about only humans, but water is needed by everybody, everything. So what about water for all the living forms, non-human living forms, or even the non-living systems, right? Water is needed for that, what we can broadly call ecology. So what about water for ecology? If we talk about sustainable development, then we have to talk about water for ecology. One of the important ways of doing that, I would say, is that when we do this demand estimations and demand planning, then we should include the water that is needed to sustain the ecology as a part of that. And now, of course, this is only one part of it, because water actually, as we know, is linked across many sectors. Water is linked to soil, water is linked to forest, water is linked to atmosphere. So this is one aspect, but accounting for water that is needed to sustain the ecology in the demand estimations is a necessary but may not be a sufficient part of it. But when we talk about water demands for ecology and we look at the entire kind of how much water will be needed for sustaining ecology, the needs of the ecosystem are actually often looked at on a different footing than the human needs. Now, obviously it's natural. Therefore, of course, any allocation of the water we do to any user or any use is ultimately a value-driven exercise, definitely. But I would say it is even more so when we talk about the water allocation for ecosystems. And I would say that in ultimate analysis, the kind of allocation that we can make or we choose to make for ecosystem needs, or the amount of water we decide to leave within the natural systems for ecosystem needs, is very strongly determined by the values and the vision. As a society, what are our collective values and what are our collective vision about water and about environment? I think this is a very strong determinant, and so we need to talk about these values and visions and what are the trade-offs that these necessitate. Okay, I think that is very important. So whenever we talk about ecological sustainability and water, maintaining the ecological integrity of water systems, we don't often talk about these trade-offs. And I think we need to talk about very clearly about these trade-offs and about both about the values and the vision which drives it and about the trade-offs. And by trade-offs, there are both. There are some things which we have to forego, some things which we may gain. Let me give an example from a different area, but of course, water has been a very strong component there also. And then I'll come to water. I think all of us are aware of the struggle of the people against the mining of bauxite at Niyamgiri in Odisha, where the local community, the Dongaria Kond community, they considered the mountain, the Niyamgiri, the Niyam mountain, as a very sacred place. It was a place where their god, the Niyam, lived. And they fought that. They said, we need to preserve our gods and our sacred places, right? And there was also livelihoods associated with that. The point is that for those people, the value of preserving that place as a sacred place was much more than the value of the millions of dollars worth in the mountain. So it's about the vision that you have for, what is the vision that you have? What is different things may have different value. Now, of course, all our choices are not that stark, and they need not be that stark. I think, sorry, my net connection had gone down. Am I back again?
You were fine. That was fine. No problem.
Okay. So all choices are not that stark, but they are all ultimately driven by what we value. For example, would we value a flowing river? Or we are okay with a river which is not flowing? That will determine our choices. And if we say that we do value a river that is flowing, then we will have to make sure that we don't build in infrastructure interventions where the last drop is removed from there, right? And we will change our mindset where we think of a river flowing down into the sea as waste to something we'll actually call it valuable. It's very valuable that it's flowing into the sea. In this context, I remember a water engineer from the water bureaucracy, I won't name required. When he was talking about this concept of environmental flows in rivers, he said water can either flow into the fields or water can flow in the river. I mean, this is not that black and white, it's only partially correct. But yes, he's right that whatever is the amount of water that we choose to extract from the river and take to our fields, that much won't be available for it to flow in the rivers. So therefore, then we need to decide how much do we want to extract, how much do we want to leave in the rivers or any other water bodies. And again, these are the trade-offs and these are the choices we'll need to talk about. The water that we extract from the river and, therefore it doesn't flow in the river. What are the uses that we are extracting it for? How critical are those uses? Or if we allow more water to flow into the river, then is it, we will have to forego some things. But how important are those uses to us? On the other hand, if the water keeps flowing in the river, maybe some new uses are being created. Like, for example, flowing water will sustain fish. The flowing water may sustain agriculture in the delta. So these are the questions we need to really talk about when we talk about environmental sustainability. These trade-offs, along with the vision. And this will be important, discussing these kind of choices and trade-offs, and the vision is important so that we can make much better informed choices in terms of sustainable management of water. And this kind of detailed understanding and discussion will also be helpful to make those choices gain much more broader acceptability in society, because then we can show what are the trade-offs and why a certain choice is better in terms of, even if we are saying that we need to forego some uses, why a certain choice is better. So these are the kind of, things that we need to talk about. So let's talk about the values and vision that we want, how we see water and how we see environment and how we see, the world around us. And then what are the trade-offs that that emerge from these choices that we make based on these values. Let's talk about all this when we talk about sustainable management. And I'll just end in a few minutes. These are just some examples, some of the important things that are very critical if we want to have a sensible, sustainable, equitable ways of managing our water. These are just some of the things which are not talked about. So we need to talk about these. There may be others also, which other people can also add. And these conversations need to happen at multiple places, among multiple groups, at multiple levels. And I think that would be the richness of it. But I also feel that it's also important that some of these conversations happen in a more systematic and structured manner, hopefully at the official levels, but even by other independent institutions, organizations, groups can also do it. And I have certain couple of suggestions in which it can be done in a more structured manner. First, I think it is very important to revisit the 1999 exercise of basin level, sector level, and national level water management, water demand assessment, which was done by the National Commission for Integrated Water Resource Development. It should be done at the national level, maybe also at some important basin levels, revisiting it with the changed circumstances, climate change, new ideas of equity, of environment, new technology, and so on and so forth. The other thing is, I would suggest a kind of a thought experiment. Suppose, look at it from the other side of view, suppose we decide that we want to leave 50% of the water flowing in the rivers and in other water bodies. Then work backwards. How much is the water then that would be available to us for other uses? What kind of uses then we can manage? And is that sufficient? Can we manage? these are the kind of things which will allow us to sharpen our understanding of these trade-offs. And the third thing I would say is that I think there is a very crucial need to revisit the infrastructure and use patterns that we have already created, whether it is for surface water, groundwater, dams, storages, all that we have created. Essentially, I think because of the kind of changes that are happening because of the changing climate, and not just that the way it will affect the water resources, but the way it will affect the demands, that is, say, for example, agriculture or so many other things. But when we revisit these existing ways of using the water and existing infrastructure and that, maybe we can also revisit the distribution and see whether we can, bring in more equity in the way these are being used. So these are some of the thoughts that I have. Of course, there may be to do this kind of rethinking in a structured manner, to talk about these less talked about issues in a more structured manner. And of course, I think there may be others people can add. And of course, it will be very nice if this can be done at an official level. But I would also say that other independent organizations also should do it. And I definitely feel that Ashoka University and this center could be one of the very, appropriate places to initiate and have some of these discussions. So I do wish that can be taken up. So with this wish, and thanking the organizers again for giving me this opportunity, I wish to end my talk by saying we need to talk about water, especially about the things that we don't often talk about. Thank you.
Thanks, Shripad. Thanks to all of you for your wonderful talks. We have a choice of taking a 5-minute break and then coming back, or we have the choice of just going through for the next half an hour. What do you think? Are you all, do you want to take a break now, or shall we just continue to speak for another half an hour in this discussion?
I'm okay, but Shripad is the guy who spoke last, so perhaps.
No, I'm okay. I'm
also okay, yeah.
Okay, I had a bunch of questions that came, and we could also look out for questions that come on the chat. There's a number of names I recognize as the people who are on either YouTube or on listening to us. So actually, I think both Shripad and I noticed your example of the woman in the well, and I thought that was a particularly nice example and that sort of leads me to this question that I'll again pose to all of you, which is exactly how do we include communities in discussions around water? And I think that is one very nice example of how a lady really pointed to a very core principle that by not having a pump, you actually expand accessibility and you encourage or incentivize, in a sense, ethical behavior around water. It's really a question of ethics and fairness and in terms of distribution. And I think Subimal has also been involving communities in a different way, in talking to them, sending your students out, looking at measurements that can be made on the ground, looking at historical records that are village and taluka specific. And that again gives them a sense of co-participation or co-creation of ideas around water that in fact that they can come back and use in their communities. So I just wanted to pose this as a larger philosophical question. This is one example that you used, Vishwanath. But in general, how do all of you see the value and the importance and the modalities of including communities in discussions around water? Modalities more than anything else. I think none of us disagree about the value and the importance and the ethical significance of that. But how do we do this better? I can start with Vishwanath and then move to Subhash.
I'll take a shot at it. But Shripad has also worked a lot more on communities, so I'm sure I'll look forward to listening to him and his points of view. And he's had great gurus also to work on, including the Pani Panchayat. So, Shripad. But for me, the point that Shripad made is that it's all about distributive justice. And distributive justice is much more of a challenge which is not talked about because the framing usually is one of scarcity. The narrative of scarcity is one of environmental scarcity, right? The water itself is not available. In my city, Bangalore, people keep saying, no, there's no water. Bangalore has run out of water and Cape Town has happened. Now, this diverts us from the real issue of distributive justice, and therefore, distributive justice cannot happen without community participation. However, community itself is a loaded word, as you all know, as we all know as professionals, that there is a class, caste, and gender divide cutting across communities. And many of the artifacts that I deal with, for example, the tanks system, is a feudal construct. These were all done during feudal times using forced labor, and land distribution was all feudal. Though democracy kicked in, perhaps it kicked in most in Kerala, but not so much in Karnataka in terms of land distribution and access to land, right? Now, when you deal with an artifact purely as a hydrological or ecological resource, you will not need the community at all. You don't need the community to design a catchment, to design channels, and you design distribution systems of dams, right? However, if you want to design it as a social good, as social hydrology, you need the community. And the question then becomes, for me at least, when I'm working with the groups there, I'm really lucky to have great women-led NGO which is doing the dialoguing there, is how do you deal with structured inequities? The inequities are structural, there is that. So perhaps the best way is to, as Shripad was mentioning, to start conversations. But then the choice is whether you want to disturb the boat or you want to not disturb the boat and incrementally gain access. What is the suboptimality and who chooses that suboptimality? One example that I want to leave you with is a lot of these tanks or these lakes have encroachment of the catchment. And this is the major challenge because water simply doesn't come into the lake. You can desilt the hell out of the lake, but water will not come in because the feeder channels have been encroached. How do you get those feeder channels clean? One way is the legal course where the Tahsildar files a petition, it goes to court and it takes 20 years. Or the other way, with many of the Dalit women where we worked with found a way, was to negotiate from a position of no power. This was to approach the landlord and said, look, if you give that 4 feet wide channel, which is 100 feet or 200 feet, the lake will benefit, you will also benefit. If you don't do so, it's your choice because you're exercising power. However, we think that it's greater good for the community if you do so. And in 95% of the cases, that land was given. Now, it was given as charity, not as a right. Are we ready to accept charity in the beginning before we fight the right battles or not? Right now, these are tough questions. And then the question asks also is who will ask these questions, who will answer these questions, and who's ready to take it. The most important part is that those questions should be asked. And it's a long way ahead to do that. Even in urban water systems, the real issue is some water for all, not all water for some. And some water for all means that a portion of the city is always scarce for water. And a portion of the city will never ever face scarcity of water. How do we address that scarce portion with the resources that's available? The narrative of scarcity for food, for water has disturbed India's sectoral approach to everything and has caused more problems, including appropriating water for so-called human needs, which is everlasting, right? So at the heart of it, Gautam, is the community and how we approach the notion of community.
Right, wonderful. Vimal?
Of course, I did little bit of work, but not much with the community. So whatever work I have done and what I found is that, I was someone till in 2019, I was working in a lab, with computer, developing models, downscaling and so on. Then suddenly I thought, let us start interacting with him and try to learn something from them, from the community. And there I have realized the first thing what is needed is that trust. So they should, trust is a very important thing. And normally, what I found is that, normally the villagers or if you go to community, they feel that, okay, they are researchers, they are scientists, they work, they don't say that papers, but their own research, but that may not be useful. We may not be able to understand. That's very hi-fi kind of thing. It will not help us. So, and then if you start telling something initially, they will think that, probably we do not understand their problem. And probably that's correct. I think that's correct. It's not probably, it's actually correct. We don't understand their problem. When we develop our tool, we think that this tool will be very useful for them. But most of the cases, what we develop is not at all useful. So the thing is that we have to understand their problem. And if you can provide a little bit of solution, we do not have to give complete solution. If we can give little bit of solution through that process, trust develops. And once the trust develops, then they will start trusting your solution. And in that way, the co-development process starts. So this is what I have found. I'm not sure if I'm correct or not, but I think that's the way things happen. And that's my opinion.
Thanks. Shripad, do you want to address that question as well?
Actually, I think Vishwanath has said a lot of the things which I, So I would just echo that, because I think those are the kind of things I would have also said. Just a couple of things I would add very briefly. One is, as he rightly pointed out, the entire, I mean, the community is not homogeneous. The community and whatever are the, even with respect to water, what are the, skewed relations which are there, they are embedded in the larger imbalance of power and position in the society. So unless that, I mean, that is the real bigger, that is the core challenge. This is a manifestation or a reflection of that larger issue into that. So I think it has to be a multi-pronged approach. And as there are no correct answers. Sometimes you start, as you said, sometimes you start with charity and then move on to rights. Sometimes you just have to start with rights. Sometimes you start with conversations. Sometimes, you might have to start with protests. It depends on the situation. But I think sometimes, at least I think two things. One is it's a big help if there are legal and official structures created where conversations can happen, where some of the divisions of caste, class, gender can be, addressed or nullified, or at least, pushed aside because of, legal spaces and some of the provisions. So that gives people something, to use as a leverage. I think those things really help. So creating those spaces and structures, I think, is very, very important. That is what I would say. And then, of course, whether they can be used or not. Like, for example, creating this, reserving a seat for women as a sarpanch. I mean, we all talked about Sarpanch Pati. This is a very well-known phenomena. And yet, it has helped, for women to kind of find that place in a major way. So those kind of things, I think are important. And sometimes the interventions themselves can bring benefits, which then can be kind of used to address some of these divisions. For example, Vilasarao Salunke always used to talk about that this whole notion of water to the landless was really very aggressively opposed, because the farmers had that water is only meant for those who are landed, right? But because the area was so drought prone and there was no water, right? So he kind of promised that, okay, if we work in this manner, we can get water. And that was used as a leverage to kind of make, way for acceptance of this. So I think there are multiple ways in which it would have to be done. But dialogue, conversation, opening, creating those spaces, I think these are all the ways to go ahead.
Thanks. So there are a bunch of questions in the Q&A, but we'll come to those. But I just wanted to ask one sort of personal question, the one that I've been wanting to ask. As a teacher, and I think all of you have also, I mean, Sukhmal is a full-time teacher, all of you others have taught. Education is a part of what you do. How do I teach at schools, and what sort of examples, what should be my approach to teaching about water, equity, ethics, usage, sensitivities in an Indian context? What are the 2 or 3 things that I would structure, even if it's a small part of a course? It doesn't need to be a full course on water as Vishwanath has taught. But if I wanted to introduce it in some general course, I teach a course called Principles of Science here. And I use many examples of different things. I teach a course called Quantitative Reasoning, again with many different examples. I'd like to talk about water, let's say, for about 4 lectures. What examples might, in your experience, might go down well? Can do the same sequence of Viswanatha and Suvimal.
But also, I'm sure that you use game theory also, or work on it and build on situations, and then force students to make choices and make critical choices and think through. So I think that's something that's important. However, I would just add a word of my experience that institutional strengthening is crucial, as Shripad was mentioning. Unless the format is governance driven, you may not find results which are easy. And institution strengthening and governance building is not something that we really teach enough. For me, because I'm an engineer, I have to give examples. The Bangalore Water Supply and Sewerage Board had a social development unit for some time, thanks to some kind of funding that came from Australia or state funding. One lady was able to get connections to 53 slums under what was called a pro-poor policy. They wound up that social development unit. From then on, there's no scarcity of water which is non-technical. The scarcity is always liters per capita per day. Whereas when that SDU was there, and she was able to reach out to communities and see what are the barriers to connection and how to get those connections going, remarkable things were done there. Unfortunately, not documented. So I think we need to pick this institutional appendages and mechanisms wherever we can find those examples and broadcast them.
Vimal?
Well, I think it's a tough question, but water is an interdisciplinary area. So one of the thing I would feel, even the way we teach water science is more like a natural water system. And we do not really consider water system as a human natural water system. And that's one of the reason because of which most of the water resources engineers could not really come up with a very good water sustainability solutions. Even the same thing is happening with most of the startups, which is not really going in a very nice way and so on. So the same thing what, Sipad was mentioning about, even water, when you're talking to, water managers, even the people from ministry. So people think that, water going to ocean, we have to stop it. And that's really bad. And one of the reason is that river interlinking may have a lot of bad impacts because it really affects the water cycle, and at the same time it has a lot of bad feedback. So I'm not discussing those technical parts, but the thing is that so we don't understand water budget, and the important part is that, and so fundamental science only tell us about for fundamental equations will only tell us about the natural water budget. So if I have to start teaching students about water budget or water system, maybe we can tell them the fundamental equations and tell them, look, you go to that, whatever monitoring system is there, let's see if there is a good monitored water state and so on, and apply your equations and find out how much gap you are getting in that budget. And that huge gap is actually coming from human system. And can you think of really understanding that human system and translating into your water budget? So in that way, and then can we really start upscaling? So I think that should be the way to really understand the water system, because it's not a natural system, it's a human natural system. But to be very frank, we failed badly. Maybe center like your center, which are looking into this problem from a completely different angle, will be successful in considering water system in that direction. So that's my brief answer to this.
Shripad?
Yeah, again, I think the advantage of following Vishwanath and Suvimal is that I actually made many of the points that I could also make. So I think I will echo those. But I'll also say that, probably I'm a wrong person to ask in terms of how to teach or how to, talk about these things in a teaching atmosphere, because I've not been a teacher like that. But because I've been a student, I would say what would be, how I would look at, a good way of learning. And in case of water, because I think as, we talked about it, the water is not just a physical or a scientific thing, right? It's a human, there is a human, non-human, and it's an interactive system that we are wanting to understand. It's not just physical systems, but it is a physical, human, other living kind of interactions. So I would say that for that, the best way to start is to, expose people, take the students to real life things. Go out, see water, ask questions, and, let them kind of trace that through, okay, the water that comes to your tap, find out where it comes from. And, then I think they would understand what are sometimes the right questions to ask. Sometimes, as Jonathan said, scarcity is not the problem. The problem is access, which is blocked because of several things. So I think that as a principle, I would say that at least in the case of water and trying to understand this nexus, it's probably just better to go out and come back with lots of questions and then try to sort out those questions and then get into more theory. And, then I think students can also understand what is the importance of theory. If you just start with theory or theoretical concepts, then it comes out as very abstract. That's what I would feel. Thanks.
There are a bunch of questions here which I'll read. And there's the first question for Vishwanath, and it says, in a place like Bangalore, where the technology and facilities are established for wastewater treatment, how do we adopt such facilities for places which lack these necessities and are in much need? How effective and efficient it is for citizens, facilitators, and environments. So, I mean, what do you do in regions where you don't have established wastewater treatment plants?
No, I answered the question on the chat, but I'll just read it out. It depends on context. So context is very important to understand and design. But there are simple oxidation ponds, which are just ponds, holding ponds, 2 or 3 of them, which do a very good job of removing 95% of bacteria and making the water ready for agricultural use. If we think of simple systems, they are the best and the most stable. So we can work out, but again, it's contextual. Now, the biggest challenge that we have is that in our urbanization process, we have disconnected the absorptive capacity of land, farmland, for let's say compost, biodegraded compost or sewage away from our settlements, right? So now settlements have to transport all this stuff to a large extent. If we are better able to integrate farmland and urban areas, then our problems become easier. So therefore, if the context is a small town or a gram panchayat, it's much easier to sort it out at that level than at a megalopolis or a metropolis.
Okay. There's a question for Subimal. In what ways do local panchayats and Krishi Vignan Kendras support farmers in making crop choices that are aligned with local water availability rather than promoting water-intensive crops due to market or subsidy pressures? Have you tried involving them in bringing necessary changes rather than depending upon social scientists and other organizations? Involving panchayats and local.
So I think crop choice making, providing correct recommendation of crop choices and convincing farmers is not a very easy thing. So, for example, I'm not sure if Krishi Vigyan Kendras really provide information related to crop choices, but of course they provide, a lot of information about the crops which they are growing, and maybe a lot of advisories related to that. But, I haven't seen the farmers actually informing us that, they're getting a lot of information about crop choices from the KVKs. But, for Kaledhan village, when we started talking to some of the with the Sarpanch. So what she mentioned is that it says she actually. So she mentioned that there are quite a number of farmers. So they don't know what exactly is the correct crop, and of course there are pressures. Maharashtra, there is a pressure to also some misinformation from different people that you have to grow sugarcane, you'll get a lot of profit, and you have to grow grapes and so on and so forth. Sometimes they are misguided, and they understand that they need a proper guide to really do that. But how to develop that trust, in what way we can demonstrate that, look, those are not correct crop. Probably this is the correct crop. This doesn't look very lucrative like sugarcane or grape, but this will give you some sustained profit which will help you in long run. So that's a different kind of challenge, and frankly speaking, I do not have an answer how to really convince them. But as I believe that developing trust is very important, this is what I have been I have been saying. But let's say at least with Kaledhan we could develop some trust, and we are trying to convince them. If we learn more from that example, then probably we'll go ahead with other villages and other people, other talukas and so on. Thanks.
Okay. I'll ask a question. This is for Shripad, the last question, and then I'll sort of wind up with one more question for all of you. And this question is, shouldn't we be doing carrying capacity studies for our water bodies and then plan/reimagine local livelihoods, infrastructure development and industrialization in every panchayat taluk district state? So rather than the sort of global central effort, shouldn't we be doing this locally is how I understand that question.
So I think, of course, there are several threads in this. The carrying capacity studies, the aim and objective normally is slightly different. But I think the core, which is kind of embedded in this question in terms of doing these kind of studies or reimagining the infrastructure development in every panchayat or taluka district. I think the core here is that we start from the smallest units like the gram panchayat or the taluka and district. And I think that is certainly definitely an important idea, that, instead of building a top-down kind of development planning, it has to be, a kind of a bottom-up approach. So I think definitely I would agree there. I think instead of reimagining local livelihoods, I think it's first more important to understand what were the traditional local livelihoods, because they have developed in kind of consonance with the local environmental conditions, water, soil, and so on and so forth. And of course, there have been huge transformations. So I don't think we can be very naive in saying that what was the situation 200 years ago is the same now. But at least it gives a very good understanding. And I think in spite of so many new developments which have happened all over the country and in each area, a lot of the core of the environment and the core characteristics still remain. So I think it's very good to understand those and then build on top of that. Now, whether to call that a carrying capacity study or some different kind of study, you can say, but I think I would say that's the way to kind of approach this issue. I'll stop here.
Yeah, so let me ask my last question. That's a sort of philosophical one. I mean, and it has to do with the value of flowing water idea that you mentioned, Shripad. I mean, when I travel and I go to many cities, especially outside India, many of them are structured around a central core that is a flowing river, as traditionally European cities or Bangkok, etc. And you realize the psychological value of seeing water flow, clean water flow, boats moving, etc. In India now, the places where you can do that are increasingly shrunk. In Delhi, the Yamuna is a sort of small little trickle. Most cities, there are very few cities where that actually are really joyfully situated around the river. They're quite small. I mean, they exist. Maybe there's one lake which has been artificially created, etc. How do we bring that feeling back? I mean, it's a broad and general question. But what did we lose? And why did we lose that sense of connection? And how do we bring it back so that people are more aware of the role that water plays?
I'll just go by the same order again, but I would always love to be the last to speak because I can then tap onto the wisdom of my previous speakers. But let me just quickly answer the one question about cultivation of crops. One of the things I have revisited is that a water efficiency perspective is one of the least important perspective for a farmer to grow a particular crop. That's what I have learned. The external notion that we have that crops should be grown based only on water efficiency is ridiculous. Pardon the use of the word. In the command areas of the tanks that I work with, the soil has been pugged over centuries as clay, and it can only grow rice paddy. At best, it can grow sugarcane. It cannot grow millets. So therefore, to give advice to people that you should grow something which is water efficient in this land is ridiculous. On the other hand, farmers have grown tomato using drip irrigation and plastic mulching, being most water efficient, and have suffered tremendous losses because the market has delivered a blow to them. So therefore, to say that we can go somewhere and advise somebody as to what his or her livelihood should be is, to me, extremely, we use the word obscene. So I think we should be very sympathetic to sugarcane, paddy, and everything else and see how and what context it grows. But to answer your question on the river water flows, I think that this is an imagined past. In India, all documents over the centuries have said that water bodies were treated very badly. They were filthy structures. Even before we knew the germ theory of disease, this was the bearer of plague, cholera, and diarrhea, right? So there was never a glorious past. The only reason why rivers would have been clean is because our population was so small that we were not able to desecrate it. So I don't come from the past, but I come from the future. And there, my thinking is more neoliberal. If we capture the true price for water, and the true price for water is when we return it back to nature in the same quantity and quality at which we appropriated it, and we deliver it to the institution which has the responsibility, capability, and accountability, then we will have a clean Yamuna. If you subsidize the rich and their snout is in the trough, if you punish the poor by making them pay the highest price for water, in the Kuznets curve of development and environment, we are at a stage that we will not clean up our rivers in the foreseeable future if we don't price water correctly. And there is the negative dividend of democracy, because no political party is willing to bite the bullet to charge a true price for water, which means you collect it and treat it and make sure that there's no industrial pollution.
Yeah, I think when you're talking about river, there are two things which happens. The first thing is, of course, we're talking about a lot about river pollution and so on. But what we have been missing is about flooding, because we have been constructing a lot of there are a couple of things. I'll go back to even the comment which made by Mr. Vishwanath. But before going to that, I'd like to mention is that the river bed, that the width of the river is actually getting reduced. We are actually constructing over the floodplains, and when you are constructing over the floodplains, of course, this is another challenge we are making. And this is something which, because of course I can answer your question, but before that I'd like to mention that the flooding part we have missed actually in this discussion, and which is actually very important. And because one of the major problem what I feel is that in the entire river basin we should have a proper flood risk map, and this flood risk map has not been done in a proper way. Even at a kilometer scale, we need flood risk map, which will tell that, look, if there is a heavy rainfall and heavy flooding, then these are the regions where there are very high hazard of flooding. These are the regions which are really vulnerable to flooding, and vulnerable means I'm talking about infrastructure vulnerability, I'm talking about socioeconomic vulnerability, and these are the regions which are really low lying, which are really exposed to flooding. So essentially, I'll go back to IPCC definition, and I'll say that what is very important for any kind of river basin, essentially river bank management, is that we need to really develop a proper flood risk map of the river basin, or river bank and so on. So that part we have not been done. For example, in Pune, I know in Ahmedabad, there is on the river bank there has lot of construction work has been done, which has been claimed that will reduce the flood. It cannot reduce, the concrete cannot reduce the flood. So it's exactly will have an opposite impact. And same thing has been tried in Pune also. I'm not sure what is the present status. I know that in the two rivers there are a lot of bank development is really taking place. So this is something which is a problematic thing, but which needs to be addressed. But I do not know how to really address. But probably one of the things which can be done is that probably we need to sit together. We have to develop the risk map and make this risk map available. We'll say that, look, even someone, if you are going, thinking that, okay, a high-rise building just on the river bank is really very nice with such a nice river view. But before buying, if he or she will look at the risk map, they will find that, okay, oh, this is very high risk. So, so is it really? Is it a good choice to really spend a lot of, few crores to really buy a flat over here? So that sort of things are probably very important. The other thing also about the crop choices, I fully agree. Actually, I have seen many papers where people have suggested that over West Bengal you shift from paddy to millet, which is really very which is very surprising to me. In West Bengal, how on that sort of soil you cannot really grow millet. So that sort of things are really, but at the same time also what is happening is that in Maharashtra I've seen that in Aurangabad, which is very dry region, where some political something is there, because of which farmers are actually growing sugarcane, and finally at the end of the day we'll see a lot of suicides and so on, because the crop failure is happening. So both the things are happening. So I think one of the solutions what is really needed is co-development, working with farmers, working with, it's an interdisciplinary area. We have to make teams and we have to address problems rather than by individuals or individual, not just by scientific community, not just by social scientists, not just by NGOs, but together let's have a lot of debate and then come up with a solution. And then that's the way, probably, that should be the way forward, I believe. Yeah, thanks.
Shripad, let me just modify my question a little bit and
Yeah.
reflect what I wanted to ask. That is, how do I make it so that a politician will come and say that, look, apart from the other thing that I will do, I will clean up the rivers that flow through the city so that everyone can come, walk past that. You will see a nice, clean, sweet-smelling river again, which you had not seen for the last 20, 30 years. What might drive a politician to do that, and how does one create the conditions for that to happen? I guess that is kind of my question.
Wonderful. I don't know. Right now, I don't have a proper answer to it, to be very frank. How to really convince a politician to really do that.
What conditions might lead to that?
Yeah. So one of the thing is, I think, probably a good cost benefit analysis is also very important, because that's something which probably the practitioners and ministry people and politicians understand, that look, you of course you're spending a lot of money, because for, let's say, if there is a epidemic which is related to water, some disease related to water, or maybe something else which is related to, or maybe just for treating it for drinking water, you are spending a lot of money. But but if you take this step, these are less costly, and finally at the end of the day, you are getting not only a better service, but at the same time a nice flowing river, which is also visually appealing, and also in many sense they are good. I don't know, frankly speaking, I don't know, but came to my mind, I've just said. Yeah.
Shripad, do you sort of sense the question that I'm trying to ask? How
I
do we?
do.
Ah,
I do. Unfortunately, because you had asked a question earlier and I had prepared my response to that, so you're going to hear that also, the response to that.
both.
But I also can't resist making a couple of remarks on this crop pattern thing. I think again, echoing both Vishwanath and Suvimal, it's ridiculous for us to go and tell a farmer that you choose this crop because it is water saving. Those are not. That may be one of the criteria, but really it's so many other things. What is the crop for which there is a market? And if there is a MSP and a assured purchase, that's really the very, very big driving force. And what are the other conditions in terms of being able to grow that crop? And this thing which you found, Vishwanath, the soil compaction and all, exactly the same thing we found in Punjab. So almost 20 years back, we did a very extensive 3-year study around the agriculture of Punjab and related to irrigation from the Bhakra Dam and that whole. And as a part of that, even at that time, there was this lot of talk about changing of the cropping pattern, which is important. The cropping pattern needs to be changed, but how? And farmers, we had extensive discussions with farmers and visits. They said we were told to switch to chili crop because there's a good market. But they said that years of paddy farming had compacted the soil in such a way that nothing else grows. And they took us to those chili farms. They said, look at how the crop is like almost a dead crop. Even though there was water, there was fertilizer, everything was there, right? So cropping pattern change is a very, very complex process, and it has to be adopted, taking the farmer. They have to, it has kind of sort of to come from them, but also it has to have this thing in mind that ultimately the farmer's livelihood has to be assured through a changed crop. Only then it will work. So I just wanted to echo that. Coming to your question, short answer to your second or newly posed question is, I think politicians will do what they sense the public wants or whatever will get them votes or acceptance. So if enough people want a clean river, then maybe the political system will say, okay, let's work for that. And that requires mobilization, that requires creating the public opinion. So, I see it as that as the answer. But, how we will see those rivers or whether we will see our rivers or not, I actually have a very more pessimistic view. Very frankly, I feel that our generation, my generation, probably, or maybe one generation after us, is probably the last generation in the country who has or will see a free-flowing river. And maybe if this continues for a couple of more generations, then the new generation may not even know what a free-flowing river is and what it looks like, and they may stop valuing it. And then as a society, it may have no value, so it doesn't matter then. This is a kind of a black or a dark reply. I'm sorry, but, this is a very likely possibility that ultimately, we may have no value for it as a society. I'm hoping that doesn't happen, but, I don't know. So I'll stop there.
On that pessimistic note, but still with understanding the value of this discussion and the fact that we've all brought very different perspectives. All of you have brought really different and interesting perspectives to this. And I think this is a good foundation for talking more about this. And I hope at Ashoka, we can see these discussions as they should be seated in different places. And I think the value of thinking about this at an intellectual level, at an academic level, at an activist level, all of this we need to put together in some way. And the challenges of teaching students about the many implications of water remain. And I hope that's something that we will be able to do better in the next 5 or 10 years to come, and provide, and hopefully the future will not be so bleak as Shripad suggested. So let me thank you all on behalf of Ashoka, on behalf of the Center for Climate Change Sustainability, and I look forward to seeing you here. Ian, did you have a few words to say at the end?
No, I love that conversation, and I was just thinking, the technical science is so difficult and complicated, but they as soon as you started getting into the community perspectives, it takes on a deeper level of complexity. And then the philosophical aspects that we touched on at the end are really, really deeply rooted, and probably arguably the most interesting, but the most difficult to disentangle. So it's been great. Thank you very much, everyone.
All right, take care.
Thank you so much. Thank you so much
Can
for
I
this.
request all of you to stay for a minute? I'll quickly take a screenshot. This will go for a report. Yes.
Okay.
And I forgot to thank various people. Asta is one person to thank. Asta has sort of set up all of this. I should thank our IT services at Ashoka and all my colleagues, the audience who sort of hung on till the end. Yeah, Asta, let's take a picture.
Thank you, Shripad and Subhimal. Learned a lot from what you said. It was really enjoyable. And thanks, Gautam, and Ian for
for me.
carrying out.
Same here, same here.
Same
I've
here.
learned a lot, yeah. Thank you.
Are we done? I think.
Yeah, we are done. Thank you so much.
All right.
Okay, thank you.
Bye, everyone.
Thank